In this video, I'm showing you how to solve for a variable in different situations, mainly in situations where you have a square, x squared in the problem, or in a literal equation. There are a couple of ways to solve this. I wanted to show you both ways because depending on whether you can use a calculator or a non-calculator or whatever method makes sense to you, it's nice to know more than one way. So when you see an x squared in a problem with no other x's, isolate the x squared by getting rid of the number that's being added or subtracted, just like you normally would. Divide by 5. You get 25. And when you see a square, you want to do the opposite, which is to square root. When you do that, the answer is plus or negative 5. You can plug in a positive 5, and you'll see that this problem works out. You can plug in a negative 5. That negative 5, when you square it, becomes a positive 5, and you will still get the correct answer for this problem. Another way of solving this problem is to factor. Find what's in common with your terms. A 5 is in common, so divide a 5 out. Then notice that x squared minus 25 is a difference of squares, which can be factored as x plus 5, x minus 5. Then where you have an x, you need to solve those parentheses. So you set each parenthesis equal to 0, and then do the opposite. And notice how we're going to get a negative 5 and a positive 5. So same answer as we got in the problem above. In a problem like this, you're working it the same way. I see a square in my problem. I see only this one x. I can isolate this parenthesis by moving the 36 over. And once you have your parenthesis isolated, get rid of the square. A square and a square root cancel each other out. Square root of 36 is actually plus or minus 6. When you move the 3 to the other side by adding 3, you really need to work two problems. You need to work positive 6 plus 3, and you need to work negative 6 plus 3. So this answer is 9. This answer is negative 3. Another way to solve the same problem is to actually multiply x minus 3 times x minus 3. Get that square off by foiling. So x squared minus 3x minus 3x plus 9. Then minus 36 equals 0. And then continue. So your like terms and more like terms gives you that. If I see a square and another variable with a different exponent, I need to think about factoring if I can. Factoring is when you create your two parentheses and you look at the last number. If there is no coefficient in front of the x squared, you look at the last number and you ask yourself what multiplies to give you negative 27 that would subtract to give you a negative 6. So x's, of course, will go in front. I know 9 times 3 is 27, and if I subtract 9 and 3, I do get 6. So we know a 9 and a 3 should go in here. I need these signs to be opposite because I need to get a negative 27. And I need the 9 to be negative because when I add negative 9 plus 3, that would give me a negative 6. Then set each parenthesis equal to 0. Add 9 to both sides. Subtract 3. And notice how I got 9 and negative 3, just like when I did the problem up here. This problem has a square and another x with a raised to the 1. I need to factor to solve this one. This one's not quite as easy as the previous problem. I teach my students to multiply the front and back. When you multiply negative 35 times 6x squared, you get negative 210x squared. Place this middle term on the bottom, and you're asking yourself, what multiplies to give you negative 210x squared? That would, and I'll look at this last sign, that would subtract to give you a positive 11x. When you look at 210, you know 21 times 10 is 210, and it so happens that if you subtract those two numbers, you get an 11. So we know it needs to be a 21x and a 10x. One of these numbers needs to be negative. When I look and think about my positive 11, I know my larger number, the 21x, needs to be positive. So the negative is on the 10. The purpose of doing this is to use it in a grouping problem I create. Take the 6x squared, put it in front. Now take these two terms, a positive 21x, a minus 10x, and now drop the negative 35. Basically, we have just written 11x in a different way. 21 minus 10 is 11. So we've written it in a different way so that we can create this grouping problem where we're going to group the first two terms and the second two terms. Factor out what you see in common between a 6 and a 21, and we've got to think about the x's, so both have an x. It would be a 3x. 6x squared divided by 3x is 2x. 21x divided by 3x is 7. On the back, we have to deal with this negative. You would want to divide out a negative number that's in common, but be careful because it's going to change this sign to the opposite. I notice that 5 will go into both of those terms. We'll divide into them. 10 divided by 5 is a 2. Don't forget about the x. Change your sign to plus. 35 divided by 5 is 7. Notice how both of these parentheses are the same, and that's exactly what you want. I am factoring out what I see in common here, which is the 2x plus 7. Factor out 2x plus 7, and you write down what you have left when you factor that out. So I would have a 3x and a minus 5. So these are the factors of 6x squared plus 11x minus 35. Now set each parenthesis equal to 0 and solve. So subtract 7, divide by 2. So look up here. This positive 7 became a negative 7, and I divided by this 2. So I teach my students to just solve this real quick. On the SAT, you are under time constraints, so every little trick helps. You know that's going to become a positive 5 when you move it over, and you're going to end up dividing by that 3. So why not do a quick shortcut, and it's always the opposite of this divided by that, and you can work it out really fast. So anytime you see these parentheses set up that way, that's what you can do. Opposite of that divided by that. There's one answer. Opposite of this divided by this. Literal equations tend to show up on the SAT. Let's say we are solving for R. When you look at this problem, we see the R. That means we want 4 and pi across. We want to put it over here on this side, but you have to follow your operations. Technically, this is 4 times pi times radius squared. To undo multiplication, you should divide. We can divide both 4 and pi at the same time. And what you do to one side, do to the other. Now we have r squared equals a over 4 pi. Again, we are undoing. Opposite of a square is a square root. So r equals a over 4 pi. We could leave it like that. We could also square root the 4 and pull it out. But for the purpose of this video, let's just leave our answer like this. And I wanted to show you one problem I found on an old released SAT test. The volume of a sphere is given by the formula V equals 4/3 pi r cubed, where r is the radius of the sphere. Which of the following gives the radius of the sphere in terms of the volume of the sphere? Before I talk about how to solve it, I want to show you if I know I'm solving for a certain variable. Everything in this problem, when it's moved over, will change to the opposite. I can quickly figure out which answer choice would be right if I just remember reverse operations. If I see a 4/3 on this side, when it gets moved over, because this is times, so I would divide by it, it will flip. So I should not see a 4/3 here. So see, that's a 4/3 and that's a 4/3. I know those cannot be my answers. It should be flipped, or the reciprocal should be written. So 3/4 and 3/4. So I could say it's going to be one of these two answers. I also know that I'm multiplying by pi on this side. So pi should be in the denominator. And sure enough, there's pi. It's in the denominator. And then lastly, if I see a cube in the problem, that means I should cube root my final answer. And here it is. So I know D has to be my answer without even solving. Just think about reversing everything that's happening on this side, and you can quickly find the right answer. So yes, I would divide by 4/3 pi, just like I did on the last problem. It's just that my 4/3 is a fraction, and it's not pretty to have a fraction within a fraction. When you learned how to divide with fractions, you learned dividing by a fraction is the same thing as multiplying by the reciprocal. So technically this should be flipped over, and you can bring the 3 to the top with the V and keep the 4 in the denominator. And now I need to get rid of the cube. Opposite of a cube is a cube root. So that would cancel it, and I would have this answer. So it's the same as that one.